Hey guys, and welcome to my tutorial on how to set up turrets. So this is just a turret that I made real quickly in Blender. It's nothing special or anything like that. I will provide it for you guys in the description of this video. There'll be a link to download it if you want to use it, if you don't have your own. But again, it's just something I whipped up real quick in Blender. It's nothing special. But as you can see, the way it works is that there's these three turrets in the scene, and they'll shoot at you in kind of like 4-round bursts. And then if you notice that the actual barrels have a little recoil effect when they fire, and if you move, then they'll move and rotate towards you no matter which way you go. And you can see this one over here. I'm currently like too far away from it. I'm out of range, so it won't even try to shoot me. But once I get in range, it'll rotate, and then it will start firing at me as well. And then you can see those ones over there will stop firing. So yeah, that's basically the way it works. The logic's pretty generic, so if you have your own turret model that you want to use, you could definitely follow along and use that model instead of this model. But with that being said, let's go ahead and jump right into it. So I'm going to be doing this from scratch, so go ahead and open up the Epic Game Launcher. And then I'm on version 4.25.3. I always recommend being on this version or newer just to avoid any potential versioning issues. And then I'm going to select Games and hit Next. And then I use the first person template. You don't have to use this one. I am using the little first person projectile, that little yellow ball that spawns. That's from this template project. So if you don't use this template project, then you'll have to make your own projectile. So I'm gonna go ahead and use this one and hit next. And then we don't need starter content, and we want to make sure we're in blueprints. And then I'll just call this the turret tutorial, and then go ahead and create the project. And then while that's loading, I'm just going to move this guy over here so I can reference it. All right, so first things first is we need to get that content added for the actual turret itself. So again, in the description of this video, there'll be a link to a folder that should contain 3 FBX files that look like this. So once you download that and unzip it, well, let's actually come back here real quick and make a new folder. Go to the content folder, make a new folder, and call it turret, just to keep things organized. And then inside of here, we'll make another folder, and we'll call it assets. And then inside of here, just take these 3 FBX files and drag them in, like so. And then you'll get a dialog window here. We want to change the import rotation to be -90 on the Z, and the reason we're doing that is because we want them to be facing along the x-axis, and Blender, I modeled them in Blender to face along the y-axis, so we need to rotate them so they're oriented correctly. And then I think I can also scale them here by 0.5 because they are a little bit big, and I think I had them scaled in my video at the beginning. So make sure you put 0.5 here for the scale and -90 for the rotation on the Z, and then you should be able to just say import all. You'll get this little warning. It doesn't really matter. And then here we go. So to make sure you have them set up correctly, or if you're using your own turret, the way the models need to look in order for them to function correctly. So I'm just going to drag them into the scene here. It's kind of in 3 separate pieces right now, but you can see the forward vector. So this is the barrel. The important part is that it's facing along the x-axis. So you see the x-axis right here. This is the red one. The barrel's going in that direction. For the base, it doesn't really matter because it's not rotating, but same for this guy. So this guy's going to go like up here basically, and then the barrels are going to go inside of it like so. So it's really important that everything on the turret is facing along this x-axis for forward. Okay, so we can go ahead and delete these from the scene. I just wanted to show you that. And file save all. And then from there, we can come back here, and we can actually create a blueprint to represent the turret. So if we just right click and say blueprint class, and we want it to be of type actor, so we'll select actor, and we will call it BP_turret. And then we can open this guy up. So inside of here, we want to add those 3 static meshes that are going to make up the turret. So we want to keep this default scene right here, but if we just click on this and then we hit add component, we want to add a static mesh for the base. So we'll say static mesh, and we will call this the static mesh base. And then over here, we can select, I forget what it's called, turret base is the one we want. You can see that adds our base. And then we want one for the top of the turret. So with this guy selected, make sure you have the base selected. We want to search, or we want to add component again, and we want to say static mesh again, and then we want to click this. And then we will call this the static mesh top, and we will change this to the turret top. But as you can see, it is attaching, or it's spawning it down here, and we want it to be up here somewhere. And we could just drag it up like this, but there's a lot better way to do this using sockets. So basically what we're going to do real quick, just leave this back here at 0, and then I'm going to tab this guy up here. So we want to come back to this assets folder, and we want to go to the turret base. So open this guy up, and then inside of here we want to add a socket for where we want the top to attach at. So to do that, it's really simple. You just hit this little create socket button, and then we can give it a name. So I'll call it the top socket. And then we can drag this to wherever we want it to be. So let's just drag this somewhere up here towards the top. It doesn't have to be like exact or anything because it doesn't really matter. And then now that we have that, we can actually come back here. You might need to, so you probably need to save this and then probably need to recompile in order for this to show up. But now if we click again on the static mesh top and under here or over here by parent sockets, there should be a little magnifying glass and you should be able to see the top socket that you just added. So if you hit that, it will snap it up to that socket. And again, if you can't see that, you probably just need to compile and save and make sure you save the changes that you've made inside of the static mesh. And so we're going to do the same type of thing for the barrels. So we want to add the barrels to be inside of here, and we're going to add 2 of them. But we want to add them at a specific location, so we need to go ahead and add sockets to the top part as well. So come back to the asset folder and come inside here and select the turret barrel. Or sorry, not the turret barrel. Select the turret top, and we want to add 2 sockets. So we'll say create socket, and we will call this the left socket, or left barrel socket. Left barrel socket. And then for this guy, we want to set it to be on the left. So we'll set the relative location to be like -20. And the Z to be 20 as well. That's maybe too far. Let's do like -10. -10 and 10. Yeah, there we go. And then we want to do the same thing for the right barrel, but obviously to the right. So I think you can right click and duplicate this. And then for this one, we want to change it to +10. And then we will call this the right barrel sockets. And then we can come back here to our turrets, and we can very simply attach those. So with the static mesh top selected, hit add component, and add another static mesh. This guy. And why did it call it turret top? I don't know. So call this one static mesh barrel L, and we will hit the little magnifying glass and select the left socket. And then we want to change this to be our turret barrel. And then I'm just going to duplicate this guy and call it barrel R, and then attach it to right barrel socket like so. All right, so now we have our turret set up and it's all attached. So you can see if we are to rotate this top part, then it rotates the barrels with it because the barrels are attached, which is nice. So just make sure we keep that at 0. All right, so now we have our turret all set up in terms of how it's supposed to look. I think in the tutorial, I took all of these guys and I selected a different material. Doesn't really matter what you select. This model isn't really like textured, or the UV coordinates are not really set up correctly because again, it's just something I made in Blender real quick. But you can throw on like a basic template material to make it look a little bit better. So yeah, okay. So now we can start actually writing the code for this thing. So first of all, let's just drag one of these into the world real quick somewhere. It doesn't really matter where. Just drag it in like so. And then let's come back here and let's go to the event graph. So the first thing we're going to want to do is set it up so that it can find the player, or find like the best target that it wants to look at. So I'm going to delete these because we don't need them for right now, because we're going to be doing stuff inside the tick function. And one thing we can do to kind of optimize this a little bit is if you go up here to class defaults, we can set the tick interval to something other than 0, because if you hover over this, it says the tick interval is the frequency in seconds at which the tick function will execute. And if it's less than or equal to 0, then it will tick every frame. So right now it's set to 0, which means it ticks every frame. But for a lot of things in your game, you really don't need them to tick every frame. Like literally every frame. Like if they ticked, at 60 FPS instead, then you could save some frames for the processor to do other stuff. So you can set this to whatever you want. I'm going to set it to like 0.0222. I don't know exactly what that comes out to. I think it's like 40 FPS or something like that. But you can basically change this value to limit the amount of times event ticks gets called, and you won't be able to tell any difference because there's not a lot of difference between ticking 200 times and ticking 60 times. You really can't tell. So anyways, let's make a function over here and call it find best target. So what this function is going to do is pretty much like it says. It's going to find the target that's closest to the turret. So, kind of figure out what the turret should be focusing on and trying to shoot at. And then in the event graph, we will call that, because that needs to happen, pretty much every tick. All right, so inside of here, we need to create some local variables to help us with this function. So we're going to create a float over here, and we're going to call it best distance. And again, make sure you select local variables down here. Make sure you're not adding them to your variable section. Make sure you add them to your local variables section, because the local variables, if you don't know what local variables are, they're basically variables that are only available when you're inside of this function. So every time this function gets called, these variables get created, and then when the function exits, these variables get deleted, because we don't need these variables outside of this function. And then we'll set it to a float. And then what I like to do for local variables is at the end, I like to put in parentheses local, just to make it obvious when you're looking at them in code. But anyway, so this is going to basically represent the best distance. So the best distance is going to be the shorter distance, because it's going to look around and it's going to find like all the players around it, and it's going to figure out which player is the closest to it. And so the best distance is going to be the distance, or the closest distance to whichever player that happens to be. And then we're going to have another one for current distance. And so this is going to be used because we're going to be looping over all the pawns in the area, or all the players in the area. And so whenever we loop over one, this is going to get set to the current distance between the turret and the character, or the turret and the player. And then we're going to be comparing these to figure out which one's the best. It'll make more sense once we start to write it. And then we're going to have another variable for the best target. This is going to be local as well, except this one is going to be an actor. So this is going to represent the actual actor that is the best. And then we're going to duplicate this, and we will call this current target and local as well. So again, this will make more sense once we start writing it, but we're going to need these variables. So the first thing we're going to want to do is we want to set the best target to, the best distance to something very high, so that when we encounter a new target, its distance will be less than this. So let's drag this in and say set. And so we basically want to set this to the max value that it can be. So in order to do that, we need to have a variable over here for the max scan distance of the turret. So I'm going to make a new variable, and I'm going to call it the, what did I call it on my other one? Yeah, sensing range, and we will make this a float. And I'm going to go ahead and add this to a private category, a constants category, because this is a constant variable, so we can select blueprint read only to make it constant, and we'll set private because nobody else needs access to it. And the reason we're doing this is because, well, if you make it blueprint read only, then you can't actually change it, and we don't want this to be changing at runtime. So you can see if I drag this in and I try to set it, it won't even let me. So it's really just a constant value to represent how far it can sense things. So you can set this to whatever you want. Basically, the higher you set this to, the further the range of the turret will be. So I'm going to go ahead and set it to 1500. And so we want to set the initial best distance to be our sensing range, and then we can just do like +1 because we just want it to be some number that no matter what target we find, it will be higher than that number. So we'll just say +1. All right. So the next thing we want to do is we want to do a sphere overlap to get all the actors that are within a certain range of this turret. So we will say sphere overlap actors. And for the sphere position, which is like the center of the sphere, we want to use the location of ourselves. So we'll just say get actor location. And then for the radius, it's going to be the sensing range, because that's how far it can sense targets. And then for the object type, we want to right click, or sorry, we want to drag off of this and say make array. And then for this tutorial, I only really care about pawns. If you want the turret to be able to target other things than like vehicles or something, then you'll have to select that here. You can just say add pin and add as many as you want, but I'm just going to select pawns so that it only targets the player. And then the actor class filter, we can just select actor. If you had like a player class that you wanted it to filter on so that it only targeted players, you could select that here and it would only target players. But I'm just going to select actor. And then for the actors to ignore, we really don't need to pass in anything because it's already going to be ignoring ourselves because we're not a pawn. But if you had actors you specifically wanted to ignore, you could pass them in here. All right, and then we will do a for each loop. Oops, for each loop. So we're basically getting all the actors, or getting all the pawns, like the player, that are within this sensing range, and then we're going to start looping over them. So this is really going to make a bigger difference if you had, like right now there's only one player, so it's always going to find the same player. Like it's either going to find the player or it's not going to find anybody. But if you had other things in your game, like other pawns, like maybe it's a multiplayer game or something, then you would need this type of logic, which is why I'm writing it. So for each loop, we will set the current target to be the current one in the loop that we are currently on. And then we want to get the distance between ourselves, the turret, and the current target. So we will say get distance 2. And then the other actor is going to be ourselves. So we can just right click and say get ref to self. And hook this guy up. And so this is going to be our current distance local. So we'll drag in our current distance local and hook that up like so. And then from there, we want to check if this current distance, so the distance between the turret and the target, which is probably the player, we want to check if that's less than our best distance, or if we currently don't have a best target yet. So we will say if this is less than our best distance, or, so we'll say or boolean, or if it is not, or if our best target is not valid. So we'll drag in our best target and we'll say is valid, and then we will say not boolean because we want to open it's not valid, like so. And then we will do a branch. So again, what this branch is checking is this the closest target so far? So just type that in. So is this the closest target so far? So is this like, because if the target, or if the turret sees one character and then it notices there's another character back behind him, it's not going to choose the character back behind him because he's going to be further away. That's basically what this is doing. So if this is going to be our new best target, then the first thing we want to do is we want to make sure that we actually have a line of sight to this target, because even if it's closer to the turret, if it's behind a wall and the turret can't see it, then we don't want the turret to target it. We'd rather the turret target something else that it can actually see that's further away. So I'm going to make a handy little function here that determines if one actor has line of sight to another one. And then since this isn't very specific to turrets, I'm just going to go ahead and throw this in a blueprint library real quick. So if you come back here, move back to the content folder. If you already have a blueprint function library, then you can just throw it in there, but if you don't, just right click, and we want to go to blueprints, and we want to select blueprint function library. And we will just call this my function library. And again, the reason we're writing it in here is because it's more of a generic function that isn't really specific to turrets. So whenever you have generic functionality that you might potentially want to reuse for other things in your game, it's good to put it inside of a blueprint function library. So open this guy up, and the function we're going to call has line of sight. And so this guy, it's going to be pretty simple. It's basically going to take in 2 locations and then determine if one location has line of sight to the other. So we will take in a vector called from and another vector called to. And then what we're going to do is we're going to do a line trace by channel. And the start is going to be our from, and the end is going to be our to. The trace channel we can leave as visibility and leave all this the same. The actors to ignore, we probably want to pass this in as well. So just drag this onto the input node, and add a pin for it, because it would be nice to allow the people calling this function to specify that. Ignore self, we can uncheck that because the self in this case is the function library, which doesn't even make any sense to ignore. And then we want to return the return value. So let's add an output parameter, and we will make it a Boolean, and we will call this, we'll just call it result. And then we want to hook this up, and we want to actually negate this, so we'll say not Boolean, because if the line trace does not hit anything, then that means we do have line of sight. Okay, so here's our handy little function. So now we can come back here to our turret, and we can say has line of sight. So the line of sight we want to check is from the turret to the current target. So if we look at our viewport real quick, we should actually really check if this guy has line of sight, because this is where the bullets are going to be coming from, this top area. So we will use that. So if we come back here, we will drag in our static mesh top, and we will get the world. Oops, I can't type get world location. That's going to be our from. Again, R2 is going to be our target, so we'll drag in our current target local, and we will say get actor location. And then the actors to ignore, we want to make sure that we are ignoring our self, which is the turret, and we also want to ignore the target. So we will drag off of this, and we will say make array, and then we'll hit this little add pin, so we can add 2 of them. So again, we want self, so just drag off this and say get ref to self. And then for this guy, we want to pass in the current target again. And that's because we want the line trace that's determining if this guy can see this guy. We want that line trace to ignore these 2 guys because we don't actually want it to hit them. We want it to hit potentially anything else that's in between them. So if it has line of sight, so we're going to do a little branch off of here. Then we can set our best target to our current target. So we'll drag in our best target, say set, and we will set that to our current target. And then our best distance, we also want to set to our current distance. All right, so we're almost done with this function. The very last thing we need to do is, if you remember, so we're inside of a loop right now. So if we come back here to our loop, the last thing we need to do is we need to set our target to whatever the best target is after this loop finishes. So let's make a little variable over here, and we will call this our target. And I'm going to add this, or I'm going to select private and then add it to a private category. And then we want to change it to an actor, like so. So we want to just set this. So off of complete here, we want to drag in our target and say set, and then hook that up, and hook it up to our best target. All right, so we're going to go ahead and run this here pretty shortly so you can see what's going on. So save everything, come back to our event graph. So again, this is running each tick, and it's finding us the best target. So I'm just going to print out the best target just so you can make sure everything's working. So we will print out our target. I'll just hook that up like so. All right, so let's go ahead and run this. So you can see it's printing out first person character because it's finding the first person character as its target. Now, if I get far away from it, it should probably stop because I'm going to get out of range. So you can see now I'm out of range. If I approach it from behind this box, it should also not work because the line of sight is returning false. It's saying, no, I don't have line of sight to the player. But if I were to jump, you'll see it saw me there for a second and then it went away because the line of sight is succeeding. Or if I walk over here, it succeeds and then it eventually goes away. So that seems to be working well. If that's not working for you, then make sure you go back and rewatch this and get it working to how it's working right there. Okay, so now that we have the best target, the next step is to rotate the turret so that it's facing that target. But we only want to do that if we actually have a target. So let's drag in our target and say get, and then let's right click here and say convert to validated get. And basically that will just let us know if the target is set to anything, because again, this function could return, this function could set our target at the end to nothing because it never found anything. So it's very possible that this target is not actually set to anything. So we want to make sure before we actually rotate that we have a target. So if we do have a target, then this is valid pin will execute. So from there, we want to call a function, and we're just going to call it update turret rotation. So let's make a function and call it update turret rotation. And we should probably take these guys and make them private as well. So it's just select private and private, and then move them both to a private category, like so. All right, so update turret rotation. So this guy should be pretty straightforward. So one thing we're going to want to take in here is the delta time, because whenever you're moving something like each frame, you need to adjust it by the delta time, so that way it doesn't move depending on your frame rate. So we'll add a parameter here, and we'll change it to a float. We'll call it the delta seconds. And so inside of here, we basically want to just end up calling, let me think. We just want to end up calling the set world location. So drag in the static mesh top, because that's the part we want to rotate, and we'll call set world rotation. And we're going to be doing this at the end, because again, this static mesh top, if we go back to the viewport, it's this piece up here. So you can see when we rotate this, it rotates the turret, which is why I'm using that piece. But basically what we want to do is we want to find the rotation from the current rotation of the top to the rotation that's needed to be looking at the target. So in order to do that, we first need to figure out the rotation that's needed in order for the turret to be looking at the target. So to do that, there's actually a handy little function called find look at rotation. And so it wants a start and a target. So the start is going to be wherever it is currently at. So we'll drag in our static mesh top, and we will say get world location and hook that up to the start. And then we will drag in our target, and we'll hook that up to the target, except we need to say get actor location because it wants a location, like so. So again, this is going to find a rotation from the like where the turret's currently rotated to where it needs to be rotated. And then we don't just want to set this immediately because we want it to interpolate to it over time. So we will say interp to constant, and we want to use this R1 for rotation, so R interp to constant. And so the target is this guy. The current value is going to be the current rotation of it, so we'll drag in the top again, and we'll say get world rotation. And then for the delta time, we can use our delta seconds. So just drag off of this and say get delta seconds, or delta second. Maybe I have to compile first, compile, and then drag off of this. Get delta seconds, there it is. So that's just this input parameter. And then the interp speed, we can just make this a variable. So right click, promote to variable, and then we'll just drag this guy into our constants because it's going to be a constant variable. So make it blueprint read only and private, and then compile it, and then we can set it to whatever we want it to be. So I'm just going to set it to like 50 or something, but basically you can change this number. The higher you set it, the faster your turret will rotate towards where it's trying to look at. And then we can call this the rotation speed, like so. So again, make sure this is set to something other than 0, or otherwise it won't work. So I have it set to 50. And then this is the value we want to use for the new rotation. But the problem is right now, if we just go ahead and hook this up, I'll show you what the potential problem is. I think that's all we need to do. So now if we come back here real quick to the event graph, we just need to call that guy. So update turret rotation, and then we need to pass in our delta seconds. I'm just going to double click the line to create a reroute node just to clean it up. All right, so let's see what this does if I play it. All right, so you can see it is rotating around to me, and then when it gets to me, it stops. But the problem with this is that the turret has no boundaries to where it can rotate. So for example, if I take the turret and I have it up here somewhere, for example, and then I run it, you can see it's like kind of clipping through the base, and it doesn't look great because ideally the turret wouldn't be able to look down that far. And again, this might differ if you're using a different turret type. Maybe it can look this far down, but if you want to clamp the values like I do, because I really don't want it to look much further down than like right here, then go ahead and do what I'm about to do next. If you don't care about that, then you can just ignore this part. So basically what I want to do is I want to clamp this value. So if we come back here to update turret rotation, and I'm just going to alt left click to unselect this and slide this over. So let's go ahead and promote this to a local variable just so we can kind of work with it easier. And we'll hook it up here, and we will call this the new rotation. So before we set it, we want to clamp this new rotation. So to do that, we can use clamp angle. So right click and say clamp angle. And then we want to split this guy because we only want to clamp the pitch value because we want it to rotate around like 360 degrees around the yaw. But the pitch is the thing we want to clamp. So if I right click and split this, we want to clamp the pitch. So if we drag in the pitch, we want to drag that into our angles, and then we can set the min and the max pitch here. So you can make these variables if you want to be able to adjust it more easily, but I'm just going to set them to like -45 and then maybe like 75 degrees upwards, so that way it can't look like directly up. You can play with these values to adjust them to be however you want, but this works pretty well, I think. And then we want to split this guy as well. And so the roll and the yaw we don't want to actually clamp, so we'll just drag those over. Maybe drag this a little bit closer. And then the pitch we want to set as our clamped pitch. So that's all we've really done. We just split this guy up, clamp the pitch, and then set it again. So now if I run this and I come back over here, you can see it still tries to rotate to me in terms of the yaw, but the pitch will clamp itself to -45 degrees. And so it won't actually be able to hit me in some cases. Alrighty, so let's go back to the event graph now that we have that working. And the last thing we need to do is get it so that the turret will actually fire at us. So let's see here, what should I do? Update fire. So let's make another function over here, and we will call this update fire, and we will drag this into the private section and make it private as well. And then inside of this guy, basically what we want to do is we want to make sure that our rate of fire has cooled down, because obviously you don't want the thing to just spam bullets every frame, because that would be kind of OP. And then we also want to make sure that before we fire any bullets that we're actually looking at the target, because obviously if we're in the process of rotating to the target, we don't want to be firing bullets because we're going to be shooting things that we don't want to shoot. So those are the two checks we're going to do, and then if those pass, then we're going to fire the gun. So in order to have this kind of cooldown system so that it's not continuously spamming, we're going to need to create a variable to keep track of when we last fired. So over here on the left, just create a variable, and we will call this the time of last fire, and we will make this a float, and we will make it private, and then we will drag it into the private category. And so what we want to do instead of update fire, because remember this gets called every frame. Well, not every frame. I mean, depending on what you have your tick interval set to, but it gets called every time the turret updates. So we want to take, we want to get the current time of the game. So we'll say get game time in seconds. So if you don't know what this is, it's basically just how long the game's been running, but it keeps takes into account if the game is paused. So if the game is paused for an hour and then you start it again, this will just return, only 5 seconds had passed, because it doesn't take into account the actual time that game was paused. So it's a good thing to use whenever you're trying to, have something be on a cooldown. So you want to take the game time in seconds, and we want to subtract, so float minus. We want to subtract the time that we last fired. So you can kind of think about this as an example. So let's say 20 seconds into the game, we fire a bullet. So this is going to be set to 20 seconds. And then the next tick or whatever, a second goes by, this is going to be 21. So it's going to say 21 minus 20. It's going to say 1. So it's going to say, okay, it's been 1 second since we fired. And then we can check if that time is greater than our rate of fire. So we'll say float greater than. And then we can promote this guy to a variable, so we can easily change it. So promote to variable. And we will call this our rate of fire. And we'll make this constant, so drag it into the constants category and set it to private and blueprint read only. And then give it a compile. And then we can set this to whatever we want. So basically whatever number you want here. So let's say if we set it to 5 seconds, then what that means is that the gun will only fire every 5 seconds, assuming it actually has a target, right? So if it doesn't have a target, it's not going to keep firing every 5 seconds. But if it has a target, it'll fire every 5 seconds. I think I'm going to bump this down to like 3 actually, so it's a little bit faster. And so we'll drag a branch off of this guy, hook that up, and then we're just going to add a little comment here, and we'll say has rate of fire cooled down, just so we know what it is. And then if it has cooled down, remember the other thing I said we were going to check is that we're actually looking at the target, because again, we don't want to fire unless we were actually looking at a target. And so to check that, we can take our static mesh top, which again is the piece that rotates, and we want to check if the angle that that guy is looking is the same angle as the direction to the target. So we will say get world location, and then we want to get a unit direction vector. So we'll say get unit direction vector, and I'll explain this here once I get it all written. Let me just write it out first. And then we'll drag in our target, and we'll say get actor location. All right, so what this is doing is it's getting a vector that points in the direction from our turret to our target. And we want to take that direction and we want to compare it to the direction that this top piece of our turret is actually facing. So we will say dot product, and then the bottom part here, we want to use the top, and we want to get the forward vector. So if you don't know what the dot product does, then I will just show you here real quick with a print string. So let me just go ahead and print this out. So print string. So we're just going to be printing out the dot product. And then let me just hook this up so it runs real quick so I can show you guys what's happening. So we're just going to call update fire back in our event tick, just after everything else. We're just going to call update fire. Oh, we're going to need to remove this just so you can see it working. So I'm just going to drag this branch down and then just hook this up just so you can see what's happening. You don't have to do this on your side if you don't want to. Actually, it might be good to check to make sure everything's working. So just ignore that check right now. So we're going to hit play. So you can see at the top left, it's printing out these numbers. So when the turret is looking at me, it's printing out 1, because whenever you take the dot product of two vectors that are exactly the same, you're going to get 1. And then the further the vectors get away from each other, it's going to approach -1. So if the turret was looking in the totally opposite direction of the player, then it would print out -1. So you can see if I start running away, it gets closer to -1. I can't really get perfectly away from it, but you can see I'm pretty close to behind it now, and it's closer to -1. It's like negative 0.6 or so. But if I were able to get exactly behind it, I would have to be up a lot higher because it's looking down as well. But if I were able to get exactly behind it, it would be -1. And you can see as it rotates towards me, it goes up until it gets to 1. So we can use that number to determine if the turret's looking at us or not. So I'm going to hook this guy back up because we're going to need that here in a second. And then we can delete this print string. So we want to just check if this number is basically 1. So I'm going to say if it's greater than like 0.999 just to give us a little bit of wiggle room. So we'll say greater than 0.99. And so if it is, then we'll add a branch. And make sure this is straight. And so this one is the turret facing the target. And if it is, then we want to fire the gun. So we need to add a little fire event here. I think I did that in my event graph before. Yeah, I did. So if we come back here to the event graph, under the event tick, I'm just going to say add custom event, and we will call this fire. And we'll fill this out here in a second, but let's come back here to our update fire, and we just want to call that fire event, so drag in the fire event. So again, just to recap, what it's doing is it is each update of the turret, it's checking if the turret has cooled down enough from the last time it fired. If it has, then it also checks if it is actually facing the target it wants to fire at. And if both of those are true, then it's going to call fire. So let's double click on fire, and we can start filling this out. So the way we want this to work, well, it kind of depends on your game, obviously, how you want your turret to fire. If you remember from my other project, so this is my other one, when it fires, it actually fires four bullets in like a burst, so 1, 2, 3, 4, and then it waits for it to cool down, and then 1, 2, 3, 4. So that's what we'll be doing, just because it's a little bit cooler than just firing 1 bullet. So inside of here, we want to, first of all, we want to set the time of the last fire to right now. So we'll drag in our time of last fire and say set. And then we will say get game time in seconds. So we're basically just saving the time, the current time, as the time that we last fired because we're about ready to fire. And then we want to do a sequence node. So if you hold down S on the keyboard and left click, it will create a sequence node. You can also do that by right clicking and searching for sequence. And we can hook this up. And then we want to do a do in. So I think if you hold down in and left click, it will do that. You can also find this one by doing do in and then maybe searching for it. I don't know what it's called. Do in times, maybe. I can't seem to find it when I search for it this way. I'm sure it's in here somewhere. There it is. Do in. But it's a lot easier to bring it up if you just hold down in and left click. But anyways, what this does is it does something in number of times. So we're basically going to set it up so that the left turret and the right turret fires. And then we're going to say do that twice. So they'll fire twice, so we'll fire a total of 4 times. So we're going to set this to 2. And we want to make it so that when this fire gets called, it's going to reset this so that it can happen again. And then after it's reset, it's going to then call enter. I know it's a little weird because they crisscross, but it's basically just resetting this and then starting it. All right, so inside of here, we want to, first of all, we want to spawn our projectile. So we'll say spawn actor from class. And the spawn transform, so let's do the left one first. So we'll drag in our static mesh barrel. And we want to get the location on the barrel that we want it to spawn from. And I think we actually forgot to do this at the beginning. So we basically just want to add a socket to our barrel for where we want the bullet to spawn at, which again is really simple. So if we come back here to our content folder, we go to our turret, assets, and the turret barrel. We just want to add a socket here to the end of it. So you can see this side has a little hole in it, and this side doesn't. So this is the back. So we want to fire the bullet from up here somewhere. So if we hit add socket, we will call this the fire socket. And then we'll just drag this guy up here to the front. It's good to put it a little bit in front of the actual front of the model, so that way it doesn't collide with it when it spawns, but set it somewhere up here. And then make sure the X, so the red vector, is facing in the direction you want the bullet to travel in. And then just say file save. And so now we can come back here and we can say get socket transform. And so that socket transform is the location that we want the bullet to spawn at, so we'll pass that in like so. And for the class, we want to select our first person projectile. Now again, if you're not using the template, if you're not following along exactly like I'm doing, you're going to have to provide your own projectile here. But you can go and you can look at the first person projectile if you need an example of how to create a projectile. It's a pretty simple class, but again, for this tutorial, we're just using this first person projectile that's already created for us, which is that little yellow ball. So that fires the projectile, and then we want to do a delay. So we'll say, I think if you hold down D and left click, it will create a delay. You can also do that by right clicking and searching for delay. And there it is. So you just want to delay a little bit amount of time between when the left barrel and the right barrel fires. So we'll say like 0.2 seconds is probably fine. And then we want to do the same thing but for the right barrel. So just copy these 3 nodes and paste like so. Except we want to change this guy to the right barrel. So if you just drag in the right barrel and put it on top, maybe it won't. So just drag this in and hook it up to the target and delete this guy. And then after that, we want to do another delay. So D left click to create a delay. Hook that up. And then we want to actually drag this around so that it comes back inside of here and to the enter. So I'm just going to clean this up so it's a little bit easier to see. So what I'm going to do is I'm just going to create some reroute nodes. So I'm going to create one here on the bottom. And then I'm going to double click and create one here on the top. And so we want to drag right here. We want to drag it into here. So come back here, we drag it, go up and around, and bam, right down there. So I know it looks a little weird right now. So if we drag this guy down and double click, we can create a reroute node. And then I'm just using the arrow keys to move it up so we can actually see what's going on. Move over here, and then double click here to create a reroute node, and then move it over here. So you can see kind of what's going on now a little bit better. So basically what's happening is the execution path you call fire, the sequence node happens, it resets this guy so that it can actually run again. That's the first thing it does, like so. And then it starts it, and so it fires the left barrel, it waits, fires the right barrel, it waits, and then it comes back here into the enter again, and since this is a do in and it's set to 2, it will do it one more time, and so it fires the left, waits, fires the right, waits, and then it comes back here again, and then it's a do in with 2, so it's already ran it 2 times, so it's going to exit. So that's basically the explanation of how that works. So let's go ahead and give this a try real quick. So if we play it, and it turns, oh, that didn't seem to fire correctly. Why is it firing in the wrong direction? Did we mess something up here? Oh, duh, because I forgot to pass in the socket name here. So we need to pass in the fire socket. Fire socket. So it actually knows where to spawn at. So now if we play it, there we go. So it spawns 1, 2, 3, 4, 1, 2, 3, 4. And it'll do that every 3 seconds or whatever you have the fire rate set to. So the final little bit of this tutorial is setting it up so that the barrels have a recoil effect. If you don't care about that, then by all means, you can stop watching the tutorial here. If you do, thanks for watching the tutorial. I have a Discord channel if you have any questions. If you like the video, please leave a like and subscribe. I also have a Patreon if you want to support me there. That's always really appreciated. Otherwise, I will see you in the next video. But for the people hanging around, we are going to set it up so that the turret has a little bit of recoil to it, which should be pretty easy. So to do that, we just need to modify this a little bit. Let me think. So the first thing we want to do is we need to create two little timelines down here to manage the current recoil of each barrel. So we'll right click and we'll say add timeline, and we will call this the recoil timeline L for the left barrel. And then we'll do the same thing for another one. So we'll say add timeline, and we'll call this one recoil timeline R for the right barrel. And so for each of these guys, we want to open them up. And all we need to do in here is we need to set the length to 0.3 because that's how long we want the recoil to last in total. And then we want to add a float track, and we will just call this the recoil. To rename this, all I did was F2 to rename it. And we want to do the same thing for the other one. Oops. So go back to the event graph, open up this guy, set the length to 0.3, and then add a float track and call it recoil. And then back in the event graph, all right, let me double check something. Yeah, that's right. And then back in the event graph, we need to assign a float track to each of these guys. So we could, you can open these up and manually add keys in here yourselves. But the thing is we want them to use the same float curve. So instead of doing the same thing in both of them for the track, we can just create a curve and then assign it to it and begin play. So if we come back here to the content folder, or maybe we should do it inside of the turret folder. Just right click and make a new float curve. So miscellaneous curve, float curve, and then we will call this the recoil curve, and we can open this guy up. So inside of here, we want to add a curve value which represents the current recoil of the barrel. So if we look at the turret real quick in the viewport, we basically want to move this gun back and then move it back forward. So you can see when I move it back, it's moving it along the x-axis. So let's say if we move it back to here maybe. So this is -50 on the x is all the way back here. And then, oops. And then obviously when there's no recoil, we want it to be back at 0. So we want it to go to -50 and then back to 0. So we'll add a new keyframe. So right click, add key, and we want to set it to 0, 0. If you ever lose track of your little triangles, just press F and it will recenter. So if I go out here and I press F, you can see it recenters. It's a handy little trick. So we want to go from 0, 0, and we want it to go back to -50, I think is what we said. So let's just right click anywhere to the right of it, doesn't really matter. Add key, and then up here we want to set the value. So we'll say after 0.05 seconds, so after 0.05 seconds, we want it to be at -50. And I'm just going to press F to get it all centered. Or sorry, press F to get it all centered. And then after a little bit, so we'll add a new keyframe. And then for this one, we want to set it to 0.3 because that's how long we wanted it to last. We want to set it back to 0. So now if I press F, you can see the whole timeline. So it goes from 0, and then at time 0.05, it's at -50, so it's going to be all the way back. And then after 0.3 seconds, and it's going to be back to 0, so it's going to be reset. And we get to save this. And then back here in our turret, in our event graph, let's go up here above everything, and let's add the begin play, so we can actually set this. So right click and say event begin play. And we want to drag in our recoil timeline L and say set float curve. And then the float curve value we want to set to our recoil curve. And then the float track name, we want to set it to recoil, since that's what it's called down here. I don't know if that actually matters. You might not have to do that, but it can't hurt. And then drag in this guy and say set float curve as well. and set it to our recoil curve and set it to recoil. So the good thing about this is that if you want to change the recoil of the barrels, all you have to do is modify this one float curve, and you don't have to modify both of them to match or anything weird. All right, so we do it for both of those. And then inside of here, we just basically want to move the barrel back a little bit and then back forward based on this timeline. So we can just drag in our left barrel and say set relative location. And again, we only want to change the x-axis because remember back here, we only want to change this direction. So we want to split this guy up. And we only want to change the x. So our recoil is going to go into our x. But for our y and the z, we want to leave them the same. So to do that, we can just drag off this and say get relative location and split this guy. And we will set the y to the y and the z to the z, so that way they don't change at all. And then we can just copy this and do the exact same thing down here. Except for this, we want to use the barrel R, so hopefully we can just drag in. There we go. Oh wait, that's not the right one. No, I messed that up. We want to drag in our static mesh. So drag in the static mesh R and hook it up to there and hook it up to there. So yeah, that's basically what it should look like. They should pretty much look the same, except one uses barrel L and one uses barrel R. So now the very last thing we need to do is actually call these timelines. So if we come back up here to our firing code, we basically just want to trigger these timelines whenever we fire. So this is where we fire the left barrel. So I'm just going to scoot this over a little bit, and then we will drag in our recoil timeline L. So if you drop down components, if you don't already have this open, you can actually drag in the timeline. So this is the timeline, and you can say play from start, which is going to start the timeline. And we want to do the same thing for the right barrel. So before the delay, let's just scoot this over. We will say recoil timeline R, play from start. And now hopefully if we did this all correct, it should work when we play it. Save everything and then play. So we can see the turret and it fires. Oh, it looks like the left barrel is, but the right barrel is not, which probably means I did a stupid mistake somewhere. Oh, right. So sorry. So down here where we have the timelines, I forgot to hook up my recoil to my X for the right barrel, which is why the right barrel was not firing. So now if we run this again, let's see, hopefully, there we go. So now both the barrels are having recoil. So if you were to add in multiple turrets to your scene, just to show you, so if you hold down Alt and drag, it will create two of them. So you can see, where's the other guy? Over here. So you see they both rotate to me and they both shoot. And if I get behind a box or something, then this guy is not trying to shoot at me until I jump, and then he tries to shoot at me. So yeah, it's pretty much working. If you guys enjoyed the video, please leave a like and subscribe. I also have a Discord channel. If you have any questions, it's in the link of the video. There's also a Patreon link. If you guys want to support me there, it's always appreciated. Otherwise, I will see you guys in the next video.